Hi, welcome to AB Video 1.4c, Part 1, More Limits of Piece Functions and Limits of Trig Functions.
So, this is still 1.4. If you were to look on page 79 in the book, we're looking at numbers 7 through 26. Basic question, find the limit if it exists. If it does not exist, explain why. So you'll notice this is a one-sided limit right here. And really, it's not going to matter. The only time a one-sided limit will matter is if you have a piece function, and that's where the two pieces separate, one on the left side of 2, one on the right side of 2. Certainly in trig functions like tan, cotan, secant, cosecant, where you have a vertical asymptote, and therefore from the right and from the left, say at pi over 2 for tan would be different. But in a regular, in this case, rational function, polynomial over polynomial, you can pretty well ignore that plus sign because it really doesn't matter. So you just plug in 2, you end up with 0 over 0, and then the traditional factor cancel, and of course the 2 minus x and the x minus 2 will cancel, but you'll be left with a negative 1, and therefore your answer is negative 1/4. Okay, an example such as the following: absolute limit is x approaches 2 from the right of the absolute value of x minus 2 over x minus 2. Remember, an absolute value is a piece function. So your absolute value of x over 2 over x over 2, this piece here it's equal to itself if that contents is greater than or equal to 0 normally. I'll come back to that in a second. Or it's negative what's in here if what's in there is negative. Now the reason I can't put the 0 is because if x minus 2 was actually equal to 0, then that would mean x is equal to 2, and of course that would cause a problem with our denominator. We'd end up with a denominator of 0. Now the denominator here, x minus 2, doesn't have an absolute value on it, so it stays as is. But as I said, if x minus 2 was equal to 0, it would not exist. So we simplify these expressions. That becomes 1, this becomes negative 1, and we isolate x. And that's the key thing here, is don't leave it as x minus 2 is greater than 0. Change it to x is greater than 2. That's why their question was, what's the limit as x approaches 2 from the right, because that's the number where the different pieces separate out. So, not that they asked for a graph, but you should be able to graph it. It's the horizontal line 1 to the right of 2 with an open dot at 2, 1. It's the horizontal line y equals negative 1 at the open dot 2, negative 1, and of course doesn't exist at 2. But now that you actually have the piece function, you come back over here. When does the limit as x approaches 2 from the right? Well, of course, that's the right side of 2 where x is bigger than 2, and your answer is simply 1. Okay, so number 16. Again, it's just a lot of algebra. You have limit as delta x approaches 0 from the right, which really isn't going to make any difference, of x plus delta x squared plus delta x minus parentheses x squared plus x all over delta x. So if you did substitute at delta x is 0, you'd get x squared plus x, and then plus delta x minus x squared minus x. So the x squares would cancel, the x's would end up canceling. And all you'd be left with is the delta x. You'd be left with, okay, I'm sorry. If you did substitute in, you'd get x squared plus x plus 0 minus x squared minus x, which would give 0 over 0. So I'm going to simplify. So I expand. If you remember, a plus b all squared is a squared plus 2ab plus b squared. Then you have the plus x plus delta x, and then I'm distributing through. So what happens is the x's cancel, the x squares cancel, and then you notice that each one of the 3 terms left has a delta x. Because again, if I did plug in delta x equals 0, I'd have 0 plus 0 plus 0 over 0. So they have a common factor of delta x. Pull it out, you're left with 2x plus 1 of those delta x's plus 1. The delta x's cancel. And remember, you're replacing delta x by 0, not x by 0. So the 2x plus, replace delta x by 0 plus 1, you get 2x plus 1. Limit as x approaches 2. Now this is very important. You'll notice there is no plus or minus as kind of in the exponent position of the 2. And that means that in order to establish what the limit as x approaches 2 of f of x is, you are, because it's a piece function, and because 2 is exactly where the two pieces might or might not connect, you are going to have to check the limit as x approaches 2 from the left of f of x and the limit as x approaches 2 from the right of f of x and see if they're the same or not. So, if I find the limit as x approaches 2 from the left, you got to decide which piece am I on the left of 2. Well, of course, the piece where I'm on the left of 2 is x is less than 2. So this is the piece I'll be plugging 2 into when I'm doing the limit as x approaches 2 from the left. Do show me which function you're using, because if you just write an answer and it's wrong, I don't even know if you knew which piece to do. So I replace 2 in here, I'll get 4 minus 8 plus 6, which is 2. Limit as x approaches 2 from the right, on the other hand, now you're looking at the function where x is greater than 2, which is the bottom function. So now I'm going to use my function negative x squared plus 4x plus 2. I'll plug in 2, and lo and behold, I get 2. Because of the fact that the limit as x approaches 2 from the left of f of x is 2, and the limit as x approaches 2 from the right of f of x is also 2, that's why we can say that the two-sided limit as x approaches 2 of f of x is 2. Okay, this is something like right off your test. Limit is pi, x approaches pi over 2 of secant x is secant pi over 2. You just substitute. That's 1 over cosine pi over 2. And, of course, the cosine of pi over 2 is 0. So you have 1 over 0, which does not exist. Okay? This is actually the first time we've had this situation, and we will talk about this later. What happens when you get a non-zero over 0. So we'll leave that for now. Now, multiple choice, one of the things you could have done is you could have actually looked at the graph of y equals the secant of x for this question. And reason being because you might want to look from the left and from the right at pi over 2. And sure enough, if you look at this graph, as you approach x equals pi over 2 from the left, you're approaching positive infinity. But as you're approaching x, as x is approaching pi over 2 from the right, the graph of secant of x is approaching negative infinity. So obviously they do not equal each other, and therefore the two-sided limit.
And that's the end of video 1.4c, part 1.